Hey everyone, this is Mike for Faraday Research. It is Wednesday night, and I just kind of completed the first stage of my new Adam's motor build. So we're going to go over all the stuff that I've done and what I've changed and what I've improved on and stuff like that. So first of all, if you haven't become a member, bottom right hand corner. Also give me a thumbs up at the end of the video if you like the video. Also, all my links are in the bottom there for Patreon, PayPal, all my donate stuff there. If you want to help fund me to keep these projects progressing in a good manner, that we can get over Unity and get these ideas out to everybody. Open source, like I said before, and I'm going to show you everything that I've done on the new build. So obviously, right away you can tell there's a difference between the old motor and the new motor. I spent a lot of time 3D printing the new case for the wheel, because I'm getting the wheel up to a really high RPM, and if anything were to fail, I'd rather have it fail inside this than out in the open. So more of a safety concern. Anything I do here, if you're not an electrician or you're not electrically educated on how to run systems like this safely, don't attempt to do any of this stuff. If you've been working with this stuff for a long time and you know your electrical and you know how to stay safe, then keep your eyes peeled and enjoy the rest of the video. So yeah, overall, the frame I put some new boards on. Actually, this board here is brand new. I painted everything now, so it looks a lot cleaner, a lot more professional looking, and easier to add stuff to if I want to. So the coil's the same, proximity sensor's the same. Remember I was talking in my last video about the two holes that I put on the side of this? Well, it turns out they were exactly correct. So it's from the coil to the reed switch, it's exactly 23 degrees. That's about the sweet spot for these Adams motors, about 23 degrees. Now, if I want the motor to actually go faster, I actually have to move the coil a little bit less, so it'd be about, say, 20 degrees. So I can adjust my coil. I'm going to be making a rig up that I can actually slide this back and forth. I'm going to 3D print something that will hold this in place, raise it up a little higher, and I'll be able to adjust it left and right, back and forth. So I can really tune the motor accordingly. Wiring. I redid a lot of the wiring. The piezos used to be on the end here. Now they're on the inside. I've also shortened the piezos, so the wires aren't as long. And yeah, so I got them taped right now just to keep the piezos separated. They're supposed to be running free. They're not supposed to be like taped down or anchored down. They're supposed to be allowed to vibrate. So that's what I did. Going back to the wheel briefly, this took me almost 9 hours to print, so that took a lot of my day. Yeah, let's go to the side here. And I got the box all hooked up. I fixed up the wiring. Now what I've done differently now is I hooked up this motor controller. So now I can hook up directly any power supply I wish, whether it's this or a battery or whatever. Hook this up now. Got the motor speed controller, and now I got my hookups. So these are actually for banana clips, so I can actually plug stuff into it. So now it's really, really easy. I just hook it up there, boom, I'm done. So I did that. I think I might even redo this again and maybe put a small little control board here. Maybe I'll do that down the road just to clean it up, make it look nice. I used a bracket for now, but it should be okay for now. Yeah, I just cleaned up the wiring, tied everything off properly. Yeah, I just refined basically everything I had from the original design. I just kind of revamped it and made it a lot cleaner, easier to locate wires and stuff like that. Basically, the running concept's still the same. Nothing has changed with that. So I've got the power supply set at 24 volts, and I can still see the amp reading on the meter as I control it with my motor speed controller now. I can go up and down whatever I want without even having to touch the power supply at all. But the great thing is now I can hook this up to batteries, whatever I wish. Easy, got all the connectors, unscrew it, or use the banana clip. So yeah, it's a lot more user friendly. So yeah, let's fire it up. I want to show everybody. I just have the one light on it now just as a ballast, just so I don't damage any of the circuit at all. So let's get it going. Get the electronics fired up. Alright, got that done. Okay, so I'm going to fire it up. Turn my power on. Let's get her going. Crank it up. Let's get the RPM going. So I got about 40 milliamps right now. Cranked all the way up. Now I can really let it rip if I want to. I can just move the advanced proximity sensor closer, and this thing really takes off. Okay, that's at 100 milliamps. This thing's just flying. But it's just fun. And it's actually pretty quiet now. It's a lot better. A lot more balanced. The motor is definitely a lot more balanced. Doesn't shake at all. There's no wobble in the shaft. It's perfectly straight. I'm just adjusting the coil here. And it's running between 40 and 50 milliamps right now. And it's over 1,000 RPM. It's about 1,200, 1,300 RPM. The one thing I do notice, since I get it up to high speed and then I back off on the timing, this thing doesn't really slow down. It continues its speed because it's built up so much inertia in the wheel. I'll just crank it up just for a second just to get it going. That's 90 milliamps and the thing's taking off. Bearings, I got ceramic bearing on the bottom, steel bearing on the top. So yeah, it's super balanced. It's just running fantastic. Really, really good. So I'll just give it a shot from the top here. And this thing actually pumps quite a bit of air, I noticed. So that's the whole device there. Runs really, really nice. Very happy with the build. So I'm going to be adding stuff to it, improving stuff as I go. It's going to be a couple other little things I'm going to work on. A couple other concepts I have in my head that I might actually try to see if they'll actually work. So now that I got the control here, I'm going to turn it down, and I could get it right down, and as you can see, as I go lower, I'm down to 20 milliamps. 20 milliamps, and it's still running pretty good. Then I could crank it right back up again, and she'll just take off. And it's so easy to control it, even with the advancing of the timing on this. Very easy to do. Just push it in and out very, very slightly. Makes a huge difference. It's got a lot of power. Like even in the wheel itself, it's got a lot of power. Like there's torque here. It's the most torquiest pulse motor I've ever built, by far. And it's so torquey. Like, this thing will put most pulse motors to shame. Like, this thing has so much torque. Very impressive. For the, like, I'm putting like 40 to 50 milliamps in, and this thing's got torque. Like, it takes quite a bit of effort to actually slow this thing down. So, yeah, pretty impressive. I think this was definitely a great upgrade from the last build. Made it look better too. More functional, easier to repair stuff. The wiring sorted out. It's more reliable wiring, you know. Wiring's everything. And yeah, it runs smooth. It doesn't wobble at all. There's no wobble. Very little vibration, if any at all. So yeah. So this is where I'm at. I'm going to be doing some more improvements to it as I go. Any questions, comments below. Give me a thumbs up if you like the video. And we'll see everybody soon when I do my next set of testing.